Imagine you leave Earth in a spaceship traveling in a straight line and you continue on this journey forever. Will you ever reach the edge of the universe? Is that even possible? This is perhaps the hardest and most mind-blowing problem in all of astrophysics, and there are really three possible solutions. Either you eventually do some kind of loop and arrive back here at Earth. Alternatively, you could continue forever and ever through infinite space, never looping back to Earth. The last and most mind-blowing solution is that maybe you'll eventually come across the edge of the universe, a barrier where all of space and time ceases to exist. This problem has stumped scientists for thousands of years, and today we are going to try and solve it together. Let me ask you a question that you might have never even asked yourself, because the answer seems so simple. Why is the sky dark at night? The obvious answer is, well, the sun isn't illuminating the surface of Earth where you are, so you get to see the true darkness of space sprinkled with twinkling stars, planets, and galaxies. But I mean, on a deeper level, why is space actually dark? Think of it like this. It's certainly true that not all of the night sky is dark, right? We can see these bright stars very similar to our sun faintly shining all around the sky, and space is full of these stars. But what if the universe were infinite and eternal? If this were the case, you should be able to look in any direction and eventually you should find a star or a galaxy. This would make our night sky as bright as the sun, no darkness. This argument is known as Olbers Paradox, named after the German astronomer Heinrich Wilhelm Olbers. 13.8 billion years ago, the universe as you and I know it today began with the hot Big Bang. At this time, the universe was completely filled with matter, antimatter, and radiation. It was extremely hot, dense, and rapidly expanding. This expansion has continued for billions of years, space itself growing faster and faster until we get to today. When astronomers look out to distant galaxies, they notice something strange. The further away a galaxy is, the faster it appears to be moving away from Earth. So what if we take this to the extreme? What if we look so far out into the universe that the galaxies are moving away from us faster than the speed of light? At this distance, the light emitted by the galaxy is moving too slowly to reach Earth. This is known as the Hubble sphere, and it's currently 14.4 billion light-years away from us in every direction. This creates a sphere of space bigger than the Hubble sphere that we can still observe. This is known as the observable universe, the true cosmic limit for everything we can possibly ever learn about. Okay, so just quickly jumping in here, and I'm currently in the Swiss Alps filming a few videos that you'll eventually get to see. But I'd like to thank the sponsor of today's video, Magellan TV. That Hubble Deep Field image that I just showed you is one of the most important and interesting images in the history of astronomy. They have an awesome documentary piece called Hubble's Legacy Field, which dives into all the awesome science conducted by the Hubble Space Telescope from the early 90s until now. General relativity tells us that space itself is not just some flat grid but rather a curved fabric of space-time where mass and energy necessarily warps the fabric itself. There are three options. Space-time can be positively curved, negatively curved something like a saddle, or finally, it can be completely flat. By looking at the cosmic microwave background, which is essentially a snapshot of the light left after the Big Bang, they can measure these angles for our universe. If the universe is truly infinite, then everything in theory could repeat, infinite Earths identical to ours with slight variations. Maybe out there in the universe there really is a version of you watching this YouTube video, but that version decides to not subscribe, while this version of you, of course, subscribes right now. 100 billion years from now, every single galaxy will be too far away from us to ever reach. In 2 trillion years, all of the galaxies will be so far away that we can no longer see them at all. The universe as we know it, all the beautiful galaxies, nebulae, clusters, all of it will slowly fade out of view beyond the event horizon. If humans evolved on a planet like Earth 2 trillion years from now, they would have never ever discovered galaxies. To them, the universe would be just their home galaxy. While this future sounds depressing, it's not really. I mean, the galaxy does have more than enough space for humanity to thrive within. If you've made it this far, you now understand the true scale, size, and shape of the universe better than any astronomer or cosmologist did just 100 years ago. Humanity will continue to explore and discover the secrets of the cosmos for billions of years. And who knows, I'm sure that by then, or even just 50 years from now, cosmologists will look back at this video in awe of just how little we really did know about the shape and size of the universe we call home.